In this video, I'll walk you through the remaining two homework problems. And so let's just start here with the third one. And here's a picture of our great uncle Claude. And he's 82 and he's going to die in 10 years. And he has $80,000 sitting in the bank. And we're going to try to help him figure out how much money can he withdraw each year so that he wipes that account out to zero when he dies, right? Why would he want to die with any money left? He'll be dead. He can't enjoy it, and he is selfish, doesn't want to leave any to his relatives. So, how much money can he take out every single year for the next 10 years if he has $80,000 sitting there? Well, we know that $80,000 represents the present value, so that's the present value. I'm going to use the formula that says the present value equals the annuity times the factor. We're trying to figure out the size of the annuity, so that means we have to figure out what the factor is, because I know the present value, 80,000. The factor is a component of taking the number of periods and the interest rate and applying that to the tables we've been looking at. So n is 10, right, because he's going to die in 10 years. And the I, the interest rate, we're assuming that he can make a very aggressive return, which is 10%. So I can go to the present value table. I need to make sure I pick the right table. I'm looking for the present value of an ordinary annuity. Go over to 10%. I go down to the n of 10. It's 6.14457. So that's my factor, 6.14457. I don't know the size of the annuity. I know the present value is $80,000. So all I have to do is solve using linear algebra. I divide the $80,000 by the factor, and I know our Uncle Claude can take out $13,019.63, and that will leave him with $0 upon his last withdrawal. Okay, so that's the answer for this third problem. The fourth problem says, okay, and this is probably more practical to you as students, you're going to graduate from here and you're going to want to go buy a car. I suggest you buy a used car, and I suggest you put a budget together rather than just going out and buying a new car. You look at your annual salary and figure out your living expenses, and then you can logically budget how much you can afford to spend each month on a car payment should you take out a loan. Perhaps you should just save the money, but let's say you're going to save the money and then go buy one with cash, but let's say you're going to take out a loan and you've determined you can save and spend, you have a budget that allows you to spend $200 every month. So you go to a bank, they're going to borrow you a sum of money, and they're going to give you a check when you leave the bank and sign the loan documents so that you can go and buy this nice new shiny car. But they look at you as a relatively high risk to their bank, perhaps. I don't know, maybe you have bad credit or something, and so they're going to charge you 12% interest rate. That's 12% per year, and they tell you can pay $200 a month. That's what your budget has allowed in it. So you tell them that you can only afford $200 a month. They say, okay, well then we'll charge you 12% interest rate, and if you pay us 40 times so at once a month for 40 months, we'll give you a big check today and you can go buy the car. So that's just another way of saying we're solving for the present value. We want to know how big the check is, what we walk out of the bank with. We know the size of the annuity. It's $200 a month. Don't let this fact that we're paying it monthly confuse you. Okay, we've looked at mostly annual payments in the past, but monthly is certainly an annuity. The size of the payment doesn't change. It's still an annuity. We got to figure out what the factor is. So we know that there's a 12% interest rate, and we make 40 payments over the life of this loan. So if I multiply the $200 times this factor, I'll know the size of the check I leave with from the bank. Okay, so if you tried to do this problem and just went to the uh, present value table, you went over to 12%, you went down to 40, and you had 8.24378. And if you got that answer, you multiplied that by 200, you got $1,600 is all the bank would give you. That's not accurate. The trick here is this is an annual rate, and these are monthly payments. You can't mix apples and oranges, so we have to take the interest rate and state it in terms of the payment period. So we pay once a month, we need interest per month, which it's 1%, right? There are 12 months in a year, so I'd take that 12% divided by 12, my interest rate is actually 1% that I'm going to use on the table, and I'm going to look for period 4. There are 4 periodic payments. So I go to my table, I go over to 1%, I go down to 40, and I find 32.83469. Right? Is that the right number? I go down over to 1%, down to 40. Yep, 32.83469. 32.83469. And I solve, that's my factor. I know the size of the annuity. I just have to multiply that by the annuity, which is $200. So they will they will write a check for $6,566. I know now what I can afford. It won't buy a very nice car, will it? But maybe just, but if you would then look at this, right, you're going to repay 40 payments at $200 a month. So 40 times 200, you're actually paying $8,000 to get a car worth 6,500 because you have to pay the difference in interest. So why don't you just save your money, take the bus, ride your bike, walk or something, and then you can buy a nicer car later on down the road. Anyway, so the answer to this problem is $6,566.